Welcome to the Keeping It Simple series for Biostatistics. This is a series that gives students a lot of trouble, but it's easy points on the exam, so hopefully you'll learn it the right way this time. I don't have any issues with it. Let's start off by talking about definitions with types of studies. The first thing we're going to talk about is a clinical trial. What's a clinical trial? Well, it's an experiment that contains two equal groups where you take one variable and change it in one group and compare it to the other group. Okay? So you take two groups, equal groups, change one variable in one group, and see what the results are. Now, what you're going to do here, you're going to use what we call double blinding. What's double blinding? That means both the doctors and the patients don't know who gets the real drug or who gets the placebo. Okay? So this way you keep it double blind, so your results are going to be unbiased. Now, you use similar study subjects to improve data validity and decrease bias. What does that mean? That means that you're going to try to find subjects that are going to be as similar as possible, both in, so like same age, same gender, same race, height, weight, right? This way you're comparing similar groups of people in this clinical trial. Now, you can have ethical concerns with this, right? Like what happens if you, would it be ethical, let's say, to have a clinical trial to study a new drug that treats hypertension, right? And you have people that have hypertension, but instead of giving them real blood pressure medication, they're getting the placebo. See that? So you're not treating them, right? So you can run into ethical concerns with clinical trials. 4 phases to a clinical trial: toxicity, efficacy, comparison, post-marketing surveillance. Well, what's toxicity? Let's say we're trying an insulin drug, okay? That means toxicity would be, does this new insulin drug have bad side effects? Phase 1. Phase 2, efficacy. Does this new insulin drug work the way it's supposed to? Comparison, phase 3. Does this new insulin drug work better than the old ones that are already available? Phase 4, post-marketing surveillance. What is that? Now that the drug has been out, it's on the market for 5 years, are we seeing any unseen or strange side effects, like it causes a heart attack, causes bowel cancer, whatever? All right? Post-marketing surveillance. Go back in time and see what happened. 4 phases: toxicity, efficacy, comparison, post-marketing surveillance. 4 phases. Let's talk about cohort study. Cohort study has several names. You can call it prospective study, longitudinal study, incidence study, or follow-up study. What does cohort mean? Cohort's a group, right? Cohort means group. That's the definition of it, is a group. So what you do in a cohort study is you observe a group of similar people to see how many people get a specific disease after exposure to a risk. So you take a group of people, similar people, see how many of them get a disease after they've been exposed to that risk factor. So what does it determine? We'll talk about these terms later. Cohort studies determine incidence. Cohort studies determine incidence. Cohort studies determine incidence. Cohort studies determine incidence. And they use relative risk. So it uses relative risk to determine incidence. It uses relative risk to determine incidence. Cohort studies use relative risk to determine incidence. Excellent. So example, find new cases of a common disease such as having a heart attack from people with asymptomatic hypercholesterolemia. How many people that have hypercholesterolemia that are asymptomatic get a heart attack? So you'll do a cohort study to figure that out, and you'll use relative risk to determine incidence. It's a case control study. This is what we call retrospective. And I'll show you a timeline here in a second. So case control study is what we call it's also known as retrospective. So this compares a group of people with a certain disease to a healthy group. So a group of people with a certain disease to a healthy group. Okay? So for example, you'll compare people with liver cirrhosis to people without liver cirrhosis to see if people with liver cirrhosis drank alcohol before they got cirrhosis. Follow? All right, so that's case control, and this uses odds ratio. Case control uses odds ratio. Case control uses odds. Case control uses odds. Excellent. So we know that cohort uses relative risk to determine incidence. Case control uses odds ratio. Cross-sectional study. It's also known as a prevalence survey. Cross-sectional study is also known as a prevalence survey. It's a slice in time. This determines prevalence. Cross-sectional study determines prevalence. Cross-sectional determines prevalence. Excellent. It's used to compare 2 different populations to try and find a possible cause of a disease in order to devise another study later. For example, researchers have found a higher prevalence of gastric cancer and diet high in smoked fish in Japan versus a lower prevalence in gastric cancer with a diet in low smoked fish in the United States. Get it? Okay, that's what we call a cross-sectional study. It's a slice in time, and it's used to determine prevalence, so total cases of disease. Trying to find the total cases of disease or the prevalence using a cross-sectional study. Okay, some other definitions. Case report describes an unusual patient case. Simple. Case series report describes several unusual patient cases. Meta-analysis looks at many studies or clinical trials and tries to find a pattern or a relationship, and that's what we call meta-analysis. So if you look at this timeline, you can kind of see where everything falls in. So you see that line that's going horizontally, that's time, and going vertically is present. So you see present is cross-sectional, future is cohort, past is case control. Got it? Past is case control, present is cross-sectional, future is cohort. Past is case control. Past is? Case control. Past is? Case control. Present is? Excellent. Present is? And future is? Cohort. Excellent. Past is case control, present is cross-sectional, future is cohort, and we discussed all those already. Let's talk about standard deviation. What is standard deviation? The degree to which individuals within the sample differ from the mean. So, it's compared to the mean. Let's talk about normal Gaussian distribution. This is what a normal bell curve looks like, all right? One standard deviation is 68%. Two standard deviations, 95%. Three standard deviations, 99.7%. Let me explain it and then we'll review it. And that means within one standard deviation, you have 68% of these people. In two standard deviations, you have 95% of the people. Three standard deviations, you have 99.7% of the people. Okay? Know these numbers. 1, 68, 2, 95, 3, 99.7. 1, 68, 2, 95, 3, 99.7. 1, 68, 2, 95, 3, 99.7. Excellent. 1, 68, 2, 95, 3, 99.7. Excellent. So let's see how this is going to show up on a test. For instance, let's pretend we're talking about IQ. Talk about the IQ test. In the middle is 100. Okay, your mean. The average person scores a 100 on their IQ test. So we can say that within one standard deviation of 15 points, okay, one standard deviation of 15 points, what does that mean? You're going to take 100, and you're going to go back 15, you're going to go up 15. So 100 minus 15, 100 plus 15. So now we have 100 minus 15, 85. 100 plus 15, 115, right? So we have 85 to 115, okay? 85 to 115 within one standard deviation. That means that 68% of the population will have an IQ score between 85 and 115, right? Two standard deviations would mean we take 15 times 2, which is 30, and minus it from 100 and add it to 100. So within two standard deviations, you have 100 minus two standard deviations, which is 30. So 100 minus 30 is 70. 100 plus 30 is 130. So between 70 and 130, you have two standard deviations of the population, which means you have 95% of the population scoring between a 70 and a 130. Everybody follow standard deviation? All right. This is your normal Gaussian distribution. One standard deviation, 68%. Two, 95. Three, 99.7. Let's do a little question here. Let's figure this out. Walk through it. Notice the percentages. So if they ask you, what percentage of scores are over 130? Well, 130 is how many standard deviations? Two. How many standard deviations? Two. And the number for two is? Two is? The two is? That's 95 like this. But I want to go above 130. So what's 100 minus 95? 5. So there's 5% left. But I want to go above 130. So I'm going to take that 5% and divide it by 2 because I'm only looking at one side of that graph. Everybody follow? So if they ask you, what percentage of the population has an IQ score above 130? You'll say it has two standard deviations. That's 95% leaving 5%, but I only want half of that because I'm going above 130, and your answer will be 2.5%. Everybody got it? Cool. Okay, standard error. What is standard error? It's an estimate of how far the sample mean is likely to be from the population mean. How far is the sample mean likely to be from the population mean? We call that standard error. N stands for sample size. Sigma is standard deviation. Okay? So SEM is your standard error of the mean. These equations, just know the equations. Okay? Nothing you can do other than know the equations. Standard error of the mean, what is this? Well, let's say you take 100 people and you do a study, and you hope that that 100 people, that study you did, is representative of the whole population, right? You take one sample and hope to be able to extrapolate that to the entire population. How far off that sample size mean, the mean of that study you did, is off from the population mean, is what we call standard error of the mean. Standard error of the mean. So how do you calculate it? Well, it's sigma divided by the square root of n. 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 Just know that equation. They're not going to probably ask you to calculate, but you might have to recognize it and put the numbers in the right place. It's easy points. Make sure you get it right. So, standard error of the mean decreases as your sample size increases. That makes sense, right? Because the more people you put in the study, the more representative it will be of the population. Therefore, if you want to decrease your standard error of the mean, you just add more people to your sample size. Everybody follow?